Okay, so today I want to work through page 15 through 18. And whatever we don't finish will be your homework. But I do want to let you know that I changed the calendar a little bit. So I'm going to push the quiz to Tuesday. Okay, quiz to Tuesday. But I don't want to lose any days. So from what we've already established in the calendar, I still want us to go through when we go through. So I didn't print out a new calendar for you because we'll be back on track by Tuesday, after Tuesday. But I will send out a daily remind to let you know exactly what I'm expecting for homework the next day. Okay, so today we'll work through pages 15 through 18. And that will be your homework for tonight, which I will check tomorrow, and I'll send out a reminder this afternoon that I'll check pages 15 through 18. Tomorrow morning, I do want to do a help session still on pages 19 through 23, which is the morning review, which I will also do Tuesday morning. So I figured that maybe some students will want to come in Friday just to do that morning review so they can kind of go back over the weekend and just look over it and practice those types of problems. But I'll also do pages 19 through 23 again next Tuesday morning of the quiz. But tomorrow, because I'm shifting these days around, tomorrow I will give you a packet number 2, which is the next packet, which is over just over first semester topics. So tomorrow we'll do limits and continuity. You guys will have homework, pages 1 through 4, which I will check on Monday. And then on Monday, we'll do pages 5 through 8, differentiation. So basically, after today, I'm not going to spend any more class time reviewing for the FRQ quiz. Okay, but this homework will be due on Wednesday. Okay, so both pages 19 through 23 and the homework from Monday will be due on Wednesday. On Monday night, I just want you to study for the quiz. And then after we get to Wednesday, then we'll be back on track from your calendar. But you can either copy this down or just wait for me to send out a remind every day, every afternoon, so you know what's coming up the next day. Okay, so I don't want you to, I don't want to give any surprises, so you'll know exactly what's coming up the next day. Okay, but after we reach next Tuesday, we'll be back on track with your calendar. But I'm just shifting those days around just to kind of give you guys a bit more time to let these problems sink in and have you guys have the weekend to look over some of these problems. Okay. Okay. The quiz on Tuesday, if you look on page 24, there is a formula sheet. I will provide that formula sheet for you on the quiz, and you'll also get to use your calculators. Okay. But a heavy emphasis is on page 19 through 23. Your quiz will look like that. The review is a little bit longer than that, but your quiz is just 2 pages. Okay, it's just so I'll just show you real quick here on page 19. Okay, I'll give you a graph, a function, and a table, and I'm just going to ask you, related problems to that stem. Okay, so just one FRQ with maybe parts on front and back. Okay, any questions? Okay, so again, I will send out daily reminders every day up until next Tuesday so that you know exactly what's coming up and what I'm expecting to check the following day. Okay. All right, so let's go to page okay, so it says f and f prime are differentiable functions. Values of f and f prime are given. If g of x equals f of x quantity squared, find the instantaneous rate of change. So basically saying find the slope at x equals 9. So before we can find the slope, we have to find the derivative. To find the derivative, let me rewrite it in the form. Maybe that'll be easier for you to recognize what rule is involved. Hey, what's involved here if I want to find the derivative? There's an outside and inside portion, right? I got that bracket squared. I got the f of x on the inside. I got to take turns with each of the derivatives there. Okay, so g prime equals outside's derivative, 2 bracket to the first power. Right, we'll just do power rule on that bracket times what's the inside's portion's derivative times f prime. Yeah. Okay, so now it's a lot easier because we have the derivative built. We just plug 9 in for x, and then we're just using the table to help grab those values down. Try that. Okay, so replace all the x's with 9s. F of 9 from the table is -2. F prime of 9 is -4. -4 times -4 is 16. Okay, part C. If k of x equals f of 3 of x times x squared plus 1, find the slope of the line tangent to the graph at x equals 3. So it's basically the same direction as part A, just a different way of saying it. We still have to find the derivative. We still have to evaluate the derivative to find the slope. Look at how this is set up though. If I want to find the derivative, I have to involve what? Product rule. Okay, product rule, because there's a multiplication operation that's separating my two expressions. But there's also a little bit of what going on with that first term. Chain rule, right? So f prime of 3x times 3, right? Outside's derivative times inside's derivative. Okay, so see if you can build out your product rule, place in all the parts, and then you can start replacing all the x's with 3 once you build your derivative. Okay, try that. Now I'll go over it with you. So product rule, f prime is that f prime of 3x times 3. G function unchanged, f unchanged, and then when we get to g prime, we take the derivative of that x squared plus 1, which is 2x. Okay, so now it gets a little bit easier. Replace all the x's with 3s, and then pull the values down from the table, or simplify with the expression in the problems. Okay, any questions with parts? Okay, part D, we've been hopefully familiar with this process here. We know that the antiderivative of f double prime is gonna make it rise up to the f prime level, but that 3x is gonna remind us that we have to do a little bit of what? First, use substitution. Okay, so use substitution. So go through that process. My u value is 3x, du dx equals 3, solve for dx, which is du over 3. So that reminds us that there's a 1/3 that's going to be part of our process here. All right, so now everything's in terms of u. It's a lot cleaner than before. So now we know that 1/3 is part of our solution. F double prime is going to rise up to f prime. The antiderivative of f double prime is going to turn into f prime. And then we can work in the bounds. But I want to make sure that we're comfortable with both methods here. One method is after you find the antiderivative, you can bring the original variable back and then use the original bounds. The other process is where we hold on to the u and convert the bounds to be in terms of u, but we'll still get the same answer, right? So here, if I were to plug 3 in for x after I converted my bounds, my antiderivative in terms of x, I will get 1/3 f prime of 9 minus 1/3 f prime of 0. Now imagine if I were here at this stage, I can plug in 0 in for x, 3 in for x, and then my bounds will be from 0 to 9, and that will give me the same thing. Right, convert the bounds from 0 to 9, hold on to my u variable, adjust the bounds in terms of u, I'll still get 9 and 0. It's just that we're taking care of that 3x either at this point or a little earlier, right? But either way, we're sitting at the same solution. Right, but what we don't want to do is we don't want to get to f prime of u and then plug in 3 and 0. And then that's wrong, right? Because this is variable u, but the 3 and 0 are in terms of x. So you either get everything in terms of x or everything in terms of u, but I can't do x's with u's, right? Because then there's a mismatch of variables. So let me just kind of point out like a multiple choice problem that I've seen in the past may look something like this. They would say, given this problem, what's equivalent to this? And then your answer would be this. Let me put it in red here. All right, the answer choice it's not asking you to go all the way. It's just asking you to find something that's equivalent to this, right? So if you were going to use substitution, you'll get that 1/3 there. And you adjusted your bounds in terms of u. So, even though this is the answer here, multiple choice, it would be asking you to match it with this to this, right? And if you didn't go through the u substitution with the bounds, then you would have a hard time matching this up. So I do want to point out this specific method. Now, obviously, if it was free response, you can decide which method to choose, but on multiple choice, sometimes they may force you into seeing if you can recognize one form versus another. Okay. Next up. Part H. Okay, the same table above here. F and F prime are differential functions. Okay. Part H says let n of x equals the integral from 0 to x squared of f prime x dx. Evaluate n of 3. So n of 3, I'm just going to rely on my formula here. Replace 3 in for the x, and then I can take the antiderivative of my function here. So n of 3, I'm not going to change anything here. I'm just going to replace 3 in for x. Okay, so this is first theorem. Okay, we can just work this through here. F prime, antiderivative of f prime. What's that going to make that f prime turn into? F of x, right? Once I find the antiderivative, I can then work in the bounds. Which gets inserted first? 9, right? So f of 9, what? Minus f of 0. Now we can look at the table of values and insert. But I do want to point something out here. Sometimes a problem may ask you, oh, what's f of 9 minus f of 0? And the hope is that they want students to understand, oh, it's just asking for us to find the area between 0 and 9 under the f prime graph. So sometimes they may kind of see if students are able to make that connection, right? This feels more straightforward, going from here to here. But then if they're asking you for this, and if they gave you a graph of f prime, you can also go back and realize, oh, this is really asking for me to find the area under the f prime graph between 0 and 9. So we do want to find f of 9 and f of 0 and subtract them. F of 9 is -2. F of 0 is 5. So -2 minus 5 is -7. Okay, next up, we want to find n prime of 3, but before we can find n prime of 3, let's find n prime of x. Let's find the derivative function. Okay, so derivative. That means I need to find the derivative of this messy expression. I'll just indicate what I want to do. I want to find the derivative of what I see there. Okay, you guys recognize this? Which process is this called? What is this called? Second theorem. So if you look on page 24, second theorem is down here. It's basically saying that my derivative and integral process will cancel each other out, but there is something that's going to occur with that upper bound. That upper bound does get inserted into the functions variable. And then we also need to multiply by the upper bound's derivative. So even though they do cancel out, there is some impact from that upper bound into the expression. Okay, so let's apply that here. So we know these two cancel out, but the upper bound gets inserted into the variable. So we're left with f prime of x squared times upper bound's derivative, which is what? Times 2x. Right. X squared's derivative is 2x, right? Yeah. essentially, but this is really kind of like a shortcut. Rather than doing the full antiderivative and then turning around and find the derivative, the shortcut is rather than doing all that, if we can just get to the answer, and understand that these two cancel each other out. That's what comes. It looks like chain rule, but it's really because this x squared shows up later because of the derivative process. I know this doesn't feel like a shortcut because I never showed you the long way of doing this, but if you were to go through this process, it would, well, first it would be difficult to do with this notation, but it would take a lot longer. Okay. But now that we're here, we can replace all the x's with what? 3, yeah. Okay, so 3n for x, f prime of 9 times 2 times 3. F prime of 9, we go to our table. That's -4. 2 times 3 is 6. -4 times 6, -24. Okay, part J. Let q of x equals natural log of f of x. Find q prime of 5. We first have to find q prime of x first before we can deal with f5. So what's involved here if I want to find q prime of x? Yeah, a little bit of chain rule, but we also see natural log here. So we have to involve natural log's derivative. What's natural log's derivative? Yeah, u prime over u. Okay, so my u value is the f of x. So what's u prime over u going to look like for my derivative? Yeah, f prime over f, right? Because my u is in place, my f of x is in place of the u. So I'm just following what the rule says, f prime over f. Okay, so now that we have the derivative, plug 5 in for the x, f prime over f5. Table of values can help get those for us. Similar process. Let r of x equals f of natural log of x, find r prime of 1. This is chain rule here. So outside times inside's derivative. What's outside's derivative? Well, what's the outside function to begin with? The f, right? So what's f's derivative? F prime. So we say f prime of natural log of x. That's the outside portion. So now we turn our attention to the inside portion, which is natural log of x. What's the derivative of natural log of x? Which is, what's natural log of x's derivative? We know that natural log of u is u prime over u. 1 over x, right? X's derivative is 1, and then over x. So it looks a little bit like J above, but the process is different because for J, the function notation is inside the parentheses, but for K, the function notation is outside the parentheses. So it feels a little bit different in the way that we approach it. Okay, so now replace every x with 1 f prime of natural log of 1 times 1 over 1. What's natural log of 1 equal to? 0. Okay, f prime is 0. Use the table. Okay. Page 17. Okay, this process, I think, will feel very kind of similar to what we've seen on that chapter 4 test. Function is continuous on the interval. We have function defined by g of x. It says find g of 2, find g prime of 2, and find g double prime of 2. Before we do that, let's go ahead and build out all of the derivatives. Okay, so we know what g of x is. I'm going to put that down. Okay, we can deal with g of 2 later. Let's build out all the derivatives. So if I want to find g prime, that's going to be the derivative of this notation. And we had a little practice with this. So let's see if we can arrive at the derivative. All right. What's the derivative of that, of this expression here? F of x squared times what? 2x. Okay, so that is g prime. Now we got to move to g double prime. But to get to g double prime, look at how this is set up here. We have to go through what? Product and chain. Yeah, so it's a little bit messier here. Okay, so let me spell out what we want to do here. F prime g plus f g prime. So f prime, what's f prime going to be? F prime of x squared times 2x. Okay, g function, no changes. F, no changes. 2x becomes 2. Okay. All right, so now we have everything in front of us. Now we can plug 2 into each of these to find g of 2, g prime of 2, and g double prime of 2. Okay, so we're gonna have to rely on the area under these graphs here. So fill this in for us here. 1/2 pi r squared. One half base times height. This is -1. This is -2. Okay, so from -2 to 4, which is 2 pi plus 2. Right? Yeah, these aren't like terms, so we have to leave this alone. Okay, g prime of 2. F of 4 times 4. F of 4 is just 0, right? That the x-intercept there. Okay, f double prime of 2, I'm just replacing all the x's with 2's, and then either pulling the slope value, the slope of the f graph, or the y value. Okay, so I get f prime of 4, what's the slope of this line segment here? Negative what? Negative 2, right? I pick 2 points along this line segment, I go down 2 over 1, the slope of negative 2. Four times 4 is 16. I just pulled that 16 out in front. 16 times f prime of 4 plus 2 times f of 4. F prime of 4 is the slope of the f graph, which is negative 2. F of 4 is the x-intercept of the graph up above, which is 0. And to combine my resulting values. Okay, next up, AB2. Okay. Let h of x equals f of 5x minus 9, find h prime of 3. We see that there's an outside inside portion. We got to go through chain rule. So outside's derivative times inside's derivative. So there's my outside's derivative. What's my inside's derivative times what? 5. Okay, make sure you don't just say f prime of 5. We can't do both at the same time. We got to do outside's derivative, keep the inside intact, and then in a separate space, we put the inside's derivative. All right, every x gets replaced with 3. F prime of 6 is asking for the slope of this line segment. What's the slope of this line segment? Okay, for the next one here, we have to do a little bit of what here? Use substitution. Now, there's something else. What do we do with that negative 4? Yeah. Well, we can't quite push it outside the parentheses. It's still under the integral, but what we can do is we can split up into 2 problems. That way it doesn't feel like as messy of a problem. Yeah, I'm just carrying that negative over here. So this piece will go through use substitution, but this piece will go through what? What's the power rule? Yeah, 4 becomes what?
Oh, it becomes
Four.
four x squared.
Just 4x, just 4x. If it was 4x, then it becomes 4x squared over 2. Yeah, so constant rising through a linear, and then we can worry about the upper and lower bound. So treat this like 2 separate problems. Use substitution for the first portion, power rule for the second, but we're gonna have to evaluate both bounds separate. I think that's the easiest way, just make it into 2 distinct problems. So -2 is the result of my first definite integral. -4 is the result of my second definite integral. Combine those two together, I get -6. Okay, so for homework, I'll let you guys finish up on page 18. Okay. And tomorrow I'll check those 4 pages. All right, I'm gonna get the phones. I'll send out a reminder each day until Tuesday. So for tomorrow's reminder, I'm gonna say I'm gonna be checking these 4 pages. I'll have a help session tomorrow going over pages 21 to 23 in the for the morning review. But the quiz is now gonna be next Tuesday. Right, so. So this is true, right? The derivative of natural log of u is prime. Right? Yeah. Therefore, the derivative of natural log of x.
Oh, okay.
Is prime over.
Okay, thank you.
How do you know this is under a rising function?
Yeah. This h prime is increasing on the entire interval. So if h prime is increasing, that means it's concave up. So if the graph is concave up, the graph looks like this. So anytime I have a tangent line, the tangent line is always going to sit below the curve because always any point on this tangent line is always going to sit below the curve because it's under approximate because the curve is shaped this way.
How do you know it's not just like how do you know it's concave up and not just like a linear, like,
It says h prime is increasing, so that means the slope is continually increasing. So that means this is slope of 1, slope of 2, slope of 3, slope of 4, slope of 5. So if the h prime is increasing, it always comes to that concave up.
okay. Okay.
Question. Because this is the f of x. It's not the f prime, it's the f of x. If it was the f prime graph, then you were looking for it there. But this is the f of x graph. So that was just kind of forward and then my work for your graph. But if this route was the main f prime, then it will be the same. Depends on what you value.
Well, you said your bag's really good. I finished the. Yeah.
The use of substitution, if you see anything inside the parentheses, that looks more complicated than the word. Basically, any kind of basically that's the reason.
No.
Yeah, you just forget. No problem. Right. Yeah, so basically, yeah, from the derivative graph, you know that anything above the x-axis represents where the slope is positive. Anything below the x-axis is negative. Anything on the x-axis is where the slope will be negative. So my zero slope is 1.
It's fine. Yeah, it's.
Here, the left of, between this interval, all these snow valleys are above the axis, so then it's on the original graph. My original graph is gonna show.
I'm so glad he is getting that. I still have some songs. That would be a relative experience.
That's right.
It's not that. So just, but it's not. It's just the place. Time zone. So you can try. So you had your two, it's year two. Why is this? That's for just. Just make sure. Way two, just makes it this. Times your. So real. Real, because your prices. 2 points. It's basically prices.
Yeah.